Hey guys, what's up? Welcome back. Today I'm going to share an interesting incident of my life with you, which I had experienced a couple of days ago. So I was riding on my bike and I was climbing this slope, okay, and I had stopped because of the signal and all this stuff. But interesting was, as soon as I started pedaling again, I applied so much of force that I accidentally did a wheel. Yes, that was the first wheelie of my life at the age of 23. Yeah, so I enjoyed that first wheelie so much that I tried doing it again and again for a couple of days. But then some of the times I succeeded in doing a wheelie, some of the times I did not. Today we are going to see the dynamics of a wheelie. And for that, as I did it on my bike, we'll be taking the bike as an example over here. So let's get started. Here we have a free body diagram of a bike. Do not look at these equations right now. We'll talk about them later. We don't need to bother about them right now. So talking about the free body diagram, we have certain forces that are acting on the bike. So let's talk about them. First of all, we have the center of gravity, which is acting downwards perpendicular to the road surface, quite understandable. H is the height of center of gravity from the road surface. F is the normal force acting on the front wheel. Similarly, Fr, normal force acting on the rear wheel. L is the wheelbase. Lf, distance between the center of gravity and the center of the front wheel. Similarly, Lr, between the CG and center of the rear wheel. Mx double dot is basically the acceleration of the bike. X double dot, because double derivative of position vector gives us acceleration. Quite simple mathematics. So this sums up the free body diagram, quite simple to understand. Now talking about wheelie. Okay, let's say the both the wheels are on the ground. So both the wheels are exerting some force on the ground, and as a result we have this normal force which is acting against them. When we do wheelie, there is no contact between the front wheel and the ground surface. Hence, we can say that if there is in wheelie, no force is exerted by the front wheel on the ground surface. So that means we need this value of F to be less or maybe zero. But let's say we are trying to prove the chances of doing a wheelie. So we can say that the lesser the value of F, the more the chances of a wheelie. So let's now talk about some mathematics about this. We'll take a moment about this point B. So FF into L plus mx double dot H minus mg Lr equals to 0. The plus and the minus sign depends on the direction of the forces that are acting. These two forces, which is the FF into L and the acceleration mx double dot into H, they are both are into same direction, that is the anticlockwise. So hence they both plus sign, and minus mglr because it is in the opposite direction, the clockwise, equals to 0. When we move these terms on the other side, we get ff equals to this entire thing. Now, interesting thing over here is this part mx double dot h by l is called the dynamic part of the equation, whereas this front part is the static part. When your bike is steady, or let's say when any vehicle is steady, we have to we should just this dynamic part does not play any role over there. So hence we are left with this mglr by l. That is the force, normal force acting on the front wheel when the body is stationary. When there is acceleration, we do need to consider this part. So now talking about wheelie, it is quite understandable from the equation that if if this dynamic part goes up, that is, if the value of this dynamic part goes up, the value of this ff will go down, which is exactly what we need to perform a wheelie. So now talking about the geometry, there are with different geometries of the vehicle, we have different cgs and different dynamics. So you might have noticed that if the center of gravity is high, then we are able to perform wheelie easily. Hence, this equation proves that if we increase the value of h, this negative part, this value of the negative part will be increased, and hence the value of ff is decreased. So this is the mathematical explanation of why the increasing the height of the center of gravity makes it easier to perform a wheelie. This is the same thing, but I just took a moment about the a-axis in order to give an equation about the normal force acting on the rear wheel. The only difference is in the sign. Here the dynamic part is in the negative, is negative. Here it's positive. For wheelie, for this video we do not require this equation, but if you are interested you can just have a look at it. So this was all about doing a wheelie on a flat surface. Earlier I told you that doing a wheelie on while climbing a slope is much easier. So let's talk about that. Let us say the slope on which I am climbing has an angle of theta. So everything will be the same, the normal force acting on the wheels, the center of gravity and all that stuff. But the only thing which will make the difference over here is the components of the weight of the body of the bike. So here we have this cos theta, the cos component, and the sine component, mg sine theta and mg cos theta. So doing the same thing again, here we had the B point, here the A point, the vehicle is climbing the slope. So taking the the moment the force is about the B point, we get this equations, and when we just rearrange the terms, the value of ff is given as mentioned over here. Now, as you can see the change, if you compare this equation with the equation previously, we have this cos component over here. This dynamic part remains the same, and we do have the weight component, the sine component of the weight over here, which is mgh sine theta by L. Yeah, mg sine theta is the height of this force is same as the height of center of gravity from the ground surface. So that's why mg sine theta into h by L. Now, as we go on increasing the angle, this theta, the steeper the slope is, the easier it will be to perform a wheelie. Why so? Let us say the value of theta is 0. Hence, we can say that we are traveling on the flat surface and we land up with the same equation as we had earlier. That is, when we replace this theta with 0, cos 0 is 1, sine 0 is 0. So this part of the equation will be gone away, and hence we'll be left with mglr by L minus mgx double dot h by L, which is exactly the equation of a bike on a flat ground. So now let us say we are increasing the angle. So with the increasing angle, with the increasing value of theta, this part will be decreasing and this negative part will go on increasing. So basically we can say that with increasing value of theta, the value of f will go on decreasing. And just to speak hypothetically, if you are climbing a road with 90-degree of angle, then this part will be 0. You will be left with just this part, like this mgh by L minus mgh by L minus mx double dot h by L. Hence there will be no, the normal force on the front will be in negative, just hypothetically speaking. So by this we have just proved that doing a wheelie while climbing a slope is quite the easiest thing to do. Let us say that you are climbing down the slope. This will be reversed. There will be the plus sign instead of minus sign, and whatever the statements, whatever the things we had till now will be just reversed. That will be the wheelie will be quite tough to do because the value of f will be just too high and will go on increasing. So considering the dynamics of the bike, considering the forces that are acting on the bike, we have just proved that how wheelie is so much easier to do with the increasing angle of the slope. Now, this free body diagram does not hold true just for the bikes. It also holds true for the you know for the motorcycles, for even for the four-wheelers. Even for the four-wheelers, you can just develop the similar kind of free body diagram, and you can this is kind of one of the most important topics when you talk about automobile engineering, that is the free body diagram. And from this, there are many things over here to consider, like the height of the center of gravity, the wheelbase, the length of the wheelbase, and so on. So from this you can also know many things if you really have a deeper look into these equations. So just go through it, develop your own, try it on your own, draw a free body diagram, and know the relations between the forces and the wheelbase and the height of the center of gravity of the vehicle and so on. Try it by yourself, and if you face any doubt doing that, just feel free to leave it down below in the comment section. I'll try to answer that question as soon as possible, and I'll see you guys in the next video.